Hello and welcome to Taki Space Program with me, Taki117. So, our Lunar Flyby satellite has entered a solar orbit and we are set up with our lunar impactor on the launch pad, and I've already got my phase angle inclination set up. We are good to go. I'm going to perform this part test contract first. There we go, problem solved. Taking care of that. Alright, launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. So this is the exact same launcher that we used the last time. I did make a few tweaks to the satellite, added some more batteries, rebalanced the antenna on it, just some basic things. So here we go. 70, 80 meters a second, 90, alright, begin our pitch over. So this one actually needs to impact the moon. So the relative inclination needs to be a little closer. Go ahead and set that there. Ooh, I need to be going down much more. You will not, good sir. There go our boosters, and once again they are destroyed by aerodynamic forces. Again, not a big deal. If anything, it is simply a minor annoyance. So this rocket I'm probably going to put in a lower parking orbit, simply because I don't need to really be up that high. As you can see, I'm yawing my rocket, trying to reduce my relative inclination ever so slightly. It's always best to make these kind of adjustments when you are low in the atmosphere going relatively slow. The main reason for that is it's easier to make adjustments slower than it is when you're going faster. As you can see here, I'm already having issues with my flight. And again, these are the same issues we had the last time. It's not unexpected to have these sorts of problems. A little bit of drift. And again, I'm going to increase my throttle. Down, I say. There we go. So this is going rather well. My apoapsis is already at 100 kilometers. I'm going to end it at 260. And we're just going to float here for a minute. And we have plenty of electric charge because I added those extra batteries. There goes our beginning to tumble again, which is fine. Just gonna warp. The main reason we're tumbling is because the atmosphere is getting thin enough that our fins down here aren't providing enough control authority. So we're going to come around again. Our relative inclination is 0.17, which is very good. Alright, there we go. Going to go ahead and deploy my payload here. And I am far enough up that deploying my solar panels isn't going to break them. I'm also going to make the switch from my launch antenna to my on-orbit antenna. If I can select it, there we go. So on orbit, we are going to go ahead and circularize. Oh hey, I've unlocked my smart stability assistance. So I can orbit prograde and force my roll to be 0 degrees. And I'm going to come over here and set up a maneuver node to circularize. Add maneuver. Oops, a little far. And as you can see, because I am lower, it's going to take less delta V to execute this maneuver. Do I have... I do not. Okay. So not a big deal. Just going to move that over here so it's out of the way. And I want to point retrograde for this. And again, the reason I'm pointing retrograde is so that my solar panels have the best chance of catching as much sun as they can. As you can see, it takes them a little while to adjust. The sun is about to dip below the horizon. Does this use any electric charge? I don't believe it does. So that's good. I am, however, going to deactivate it for the moment because I don't need it. And we're going to warp to that maneuver. Now, as you can see, because I have so much more electric charge, I'm not losing my connection like I was before. I'm actually going to point towards the node now. Now, hopefully, this rocket... go ahead and activate it. But hopefully, because my probe payload is much more balanced, this rocket will, it won't flex as much, for lack of a better word. There's the moon there. So what I'm going to do is I'm going to do a small test burn. Now, as you can see, we are going to run into the same issue we had previously, where for some strange reason my rocket is unbalanced. I'm not sure why that is. Like I said, everything is more or less the same. I got rid of the things that would be unbalanced, and I didn't figure that having a weight difference of so little would be such a big issue. But it's not a problem. All we're doing is getting into orbit. Our relative inclination to the moon is 0.14 degrees, and I can go up to about a quarter throttle. So I can go up to 1/4 throttle without issue. So my moon is set as the target, and the way I like to do this is I'm going to set my focus to the Earth. There we go. I'm going to zoom out, and I'm going to place the moon at about the 3 o'clock position. And then I'm going to add a maneuver at the 9 o'clock position of my orbit and pull prograde. And this should give me an intercept. Whoa, overshot that. There it was. There it is. So, again, need to slide just a little bit. Pull prograde. I want to keep an eye on my lunar periapsis. Oh. And there we go. Now we have an impact trajectory with the moon. It's going to take us a little bit to get there because we just passed that point in our orbit, but it's fine. We'll get there eventually. So we're going to go ahead and warp around. I'm going to point towards the node. As you can see, I'm generating much more electric charge. The range on this is 3 megameters, or 3,000 kilometers. So hopefully I can perform this maneuver and make the switch and still be able to generate enough power. So here we go, orbiting the Earth. Beautiful that is. Coming around the dark side. Or the night side, if you want to be technical. This burn is going to take 37 seconds. So I should start my burn about 18 seconds prior to the node. Oops, and I miss it. Oh well. Like I said, not a big deal. Just lower our thrust and let our spacecraft compensate. This is going to be a bit of a burn. So I'm going to physics warp. Now, to physics warp in space, you press the Alt key and then your warp buttons. This allows you to warp while burning your engines, for instance. Because I'm performing a rather long burn with very little thrust, it's going to take a while. So here we go. 200 meters a second. Let's see how our orbit is doing. It's doing nicely. I don't think we're going to actually hit the moon. I might have to make a correction. So. And hey look, we actually hit the moon here. So there we go. I'm going to point prograde. Program seems to work well for what I'm doing. There's Luna 2. Luna 1 is somewhere. Let's zoom out, shall we? So there's Luna 1. But you can see its orbit because of the gravitational kick from the moon. It's known as a gravity assist. It's almost out to the orbit of Mars. So this is why NASA tries to use gravity assists. Go ahead and refocus on Luna 2, way down here. It's a good way to increase your orbit without using a whole lot of delta V. So we're going to go ahead and warp. Oh dear. I am still connected. However, I need to switch rather quickly. There we go. Okay, so I am generating enough power to power my dish, my one dish, and still have a positive power output. This is good. This means I've solved the major problem with this spacecraft. So this is a viable lunar communication satellite. I still need to fix the issue with the engines, but that will come later. You know, as I get more technology, as I get better engines, I will be able to adjust accordingly. Now this, you may be wondering, I'm at 37 megameters right now, and this antenna still had a connection. That's because it's 3 megameters from the closest satellite, which in this case is probably one of my ComSats at 1 megameter. Here, I got lucky, and ComSat 2 is less than 3 megameters from where I am. So, in that regard, I got really lucky. Now again, this probe isn't designed to land. It's not designed to do anything other than send back some science data from space around the moon and hit the thing. Shouldn't be hard, right? I mean, it's the moon. Why am I... Oh. So I still need to face the sun. It's actually pretty close. So there's our pale blue dot. You got Saturn over there in the distance. Just gonna keep going. And once again, I'm going to slow down my warp as I approach this sphere of influence boundary, because, again, weird things can happen. I get an alarm at 15 minutes saying I should probably pay attention. And then at about a minute, I try to get as close as I can. I stop warp, and now I'm going to adjust to face the sun. Oop, and we just crossed into the moon's sphere of influence. So So I'm going to orbit prograde, see where that puts me. Actually, I'm going to kill it right about there. Because I need to face this way. Because I want as much sunlight as I can possibly get. So that should be good. I'm going to activate my magnetometer, log that, transmit that back, see how much power that takes. Okay. So we've completed our transmit science data. We still have quite a bit of power left, so I'm going to turn that off, and I'm going to transmit my telemetry. Takes a little bit more power, not a big deal. And I'm going to observe my materials bay. That doesn't get me any science, but I'm going to transmit it anyway because I'm sure it will be useful somewhere down the line, because who knows. Now we're going to warp a little bit more. So we are still high over the moon. And it looks like I'm probably going to lose my connection because I'm going to be crashing on the far side. So, kind of a problem, kind of not. So, before I lose my connection, I'm going to... I'm near the moon. Good. So, I'm going to transmit my telemetry. I'm going to activate my magnetometer and log that data and transmit it. And deactivate my magnetometer so I'm not using up electric charge. And then we're going to go... And I've lost my connection because the Earth is being blocked by the moon. If I check my satellite here... Oh. So basically, because the Earth is on the other side of the moon, I can't talk to it. I have no way of contacting the Earth. But you know what? That's okay, because this satellite is doing exactly what it's intended to do, which is smash into the surface. So here we go. We are 8 kilometers from the surface. Five kilometers. We're coming down almost 800 meters a second. And there we go. Smashed successfully into the surface of the moon. As you can see, this should have completed our contract. That's weird. So, we're going to go back to the Space Center. And that completes our episode. We've successfully crashed into the moon, telling us that landing is possible. Now, it's going to take a little bit of timing to get there, but it can be done. I also need to go back and redesign my satellite. Oh, it did complete. Okay, so we did successfully complete that contract, and wow, that is a lot of science. So, I'm going to go to our research and development. I need advanced construction, definitely. Fuel, definitely. And I don't have any, I don't have enough science for anything else, unfortunately. But it looks like we have some really cool things coming up in the next couple of tiers. Lots of engines, lots of fuel tanks. I'm surprised I don't have fuel lines yet. But it's not a big deal. We get specialized construction. We get, looks like RCS thrusters and things. Bigger and better command pods, but we'll get there. We will get there eventually. So I need another, let's see, 90, looks like 135 science to complete this tier before I move on to the next one. But as we move on and up the tiers, going to the moon will get easier and easier, and we can eventually start setting our sights on Mars. So, until next time, I'm Taki117. Thanks for joining me, and remember, it's only rocket science.